Okay students, so let's get started. With capacitance A2 physics se past paper. Let's see this first question. A capacitor consists of two parallel metal plates separated by air at a variable distance x apart as shown in figure 6.1. Okay, the capacitance is inversely proportional to x. What does this mean? This basically means कि जो capacitance है, this is inversely proportional to x, that is the distance between the two plates. Okay, the capacitor is charged by a supply so that there is a potential difference V between the plates. State expression in terms of C and V for the charge on one of the plates and for the energy stored in the capacitor. बेटा capacitance का formula क्या होता था? Charge divided by voltage. तो अगर मैं charge को इसमें subject बना दूं, what will be the formula? Charge is equals to CV. So place here CV. Energy का क्या formula हुआ करता था? Energy का formula used to be equal to 1 upon 2 QV. Either you can write this या फिर आप Q को CV से replace कर दो. This is the first formula of energy. And the second formula of energy is by replacing Q by CV. Replace it, see what the formula comes out to be. CV square is equals to your energy. I am writing 1 upon 2 CV square wala. Just it's a personal preference. ठीक है, चलो let's further move ahead. The charge capacitor in A is now disconnected from the supply. The plates of the capacitor are separated by a distance L. Okay, अब distance L हो गया separation का, ठीक है. They are then moved closer by a distance D, okay, as shown in figure 6.2. Okay, state the expression in terms of CV, L and D for capacitance nu. ठीक है, देखो बेटा initially distance क्या था? L, and let's say initially capacitance थी C. C capacitance पे initially हमारा distance क्या था? L. And we know that capacitance and the distance are inversely proportional. So what I can do here, I can remove the sign of inverse proportionality. ये constant आ गया K, this L. This K is the constant of proportionality, nothing else. Constant of proportionality, nothing else. ठीक है, proportionality. Now what can you do here? You can multiply L and C. This will become what? C L is equals to your constant K. This is your first equation. Now what you have done is कि आपने distance D से decrease कर दिया है. What is this resulting distance? ये distance कितना हो जाएगा भाई? ये distance हो जाएगा L minus D. Okay. So C nu is equals to K divided by L minus D. Multiply both of them. C n L minus D is equals to K. This is my second equation. Okay, this is my second equation. Now equate both of them together. C L is equals to C n L minus D. Bring L minus D in the denominator. C L divided by L minus D is equals to your C n. So capacitance for the new capacitor comes out to be what? CL divided by L minus D. Simple as that. So now let's move on to part 2. You have to calculate the new charge. Now always remember that if you decrease the length or increase the length, the charge on the capacitors will remain same. तो initially जो charge था वही charge यहाँ पे भी आ जाएगा, that is CV. Now what is the third part? Calculate the new potential difference. Did we study the formula के capacitance is equals to charge divided by voltage. इसमें voltage को subject बना लो. Voltage is equals to charge divided by capacitance. Charge की क्या value आ रही थी? CV. Capacitance new की क्या value आ रही थी? 1 second, we had calculated it here. CL divided by L minus D. Okay. CL divided by L minus D. क्या होगा भाई? C and C cancel out हो जाएगा. L minus D will get multiplied above. Voltage L minus D divided by L is your new voltage. This is your VN. ठीक है, you can encircle it here as well, या put a box here as well. Explain whether reducing the separation of the plates in B results in an increase or decrease in the energy stored in the capacitor. Okay. So बेटा energy stored का एक formula हुआ करता था that used to be equal to 1/2 Q V. Now the charge remains constant. This is constant and this is constant. So energy is directly proportional to the voltage. Let's see whether the voltage will increase or decrease. If you see here, voltage is getting multiplied by a fraction that is less than 1. क्यों less than 1? क्योंकि L minus D की वैल्यू हमेशा L से कम होगी. So this fraction which I have highlighted in yellow will always be less than 1. So your voltage has decreased. So your energy will decrease as well. ये थोड़ा सा दिमाग वाला सवाल था, ठीक है. Let's check in the marking scheme as well whether we are correct or not. Yes, decreases. ठीक है. यहाँ पे अलग रीजनिंग लिखी हुई है. Because oppositely charged plates attract, so energy stored decreases. ठीक है, ये भी हो सकता है आंसर. ठीक है, perfectly fine. Other answers हमारे correct है. Let's move on to the next question. Let's see part A of this question. Two flat plates are held a small distance apart by a means of insulating pads as shown in figure 6.1. Okay. Explain how the plates act as capacitor. भाई ये जो plates हैं वो capacitor की तरह किस तरह act कर रही हैं? So let's write down the answer. When potential difference is applied, across the plates, it causes the charge to separate. It causes the charges to separate, and hence energy is stored. Simple as that. और capacitors का one of the function क्या है? To store energy. The arrangement in figure 6.1 has a capacitor C. Okay, the arrangement is connected into the circuit of figure 6.2. Okay, when the two-way switch is moved to position A. ठीक है, जब ये switch आपने position A पे move किया है, something like this. ठीक है, इस तरह जब आपने position A पे switch को move किया है. ठीक है, चलो. The capacitor is charged so that the potential difference is V. ठीक है, जब आपने स्विच को A पे मूव किया है तो कैपेसिटर चार्ज हो जाता है such that the potential difference across the capacitor is V. Okay. When the switch is moved to position B, something like this. यार कुछ अगर इस तरह हो जाए, something like this, ठीक है, something like this. ठीक है, तो the capacitor fully discharges. ठीक है, when you move the switch to B, the capacitor fully discharges. When you move it to A, the capacitor charges with a voltage of V. Okay, the switch moves repeatedly between A and B. Okay, repeatedly move कर रहा है between A and B, so that the capacitor charges and discharges with a frequency of this. Okay, show that the average current in the ammeter is given by this value. Okay, बेटा करंट की क्या फॉर्मूला होता था? Q डिवाइडेड बाय T. Q को हम किससे रिप्लेस कर सकते हैं? सिंस इट इज अ कैपेसिटर CV से. एंड 1 डिवाइडेड बाय T किसके इक्वल होता है? 1 डिवाइडेड बाय T इज इक्वल टू योर फ्रीक्वेंसी. सो व्हाट कैन वी राइट हियर? CV इनटू योर फ्रीक्वेंसी F. हेंस वी हैव प्रूव्ड दिस. चलो लेट्स फर्दर मूव अहेड. फॉर अ पोटेंशियल डिफरेंस ऑफ 180 volts and a frequency of switching 50 Hz, the average current is this. Okay, voltage given है, frequency given है, current given है. You had to calculate the capacitance. तो आपने क्या करना है? ऊपर वाला फॉर्मूला नीचे लेके आ जाओ. I is equals to CV F. I is equals to CV F. करंट किसके इक्वल है भाई? करंट इज equals to 2.5 into 10 raised to the power of -6. कैपेसिटेंस हमने निकालनी है. वोल्टेज किसके इक्वल है? 180. फ्रीक्वेंसी किसके इक्वल है? 50 Hz. Can I calculate the capacitance? Yes, surely I can. Let's put it inside the calculator. 2.5 into 10 raised to the power of -6 divided by 180 divided by 50. This comes out to be 2.8 into 10 raised to the power of -10. Capacitance C comes out to be 2.8 into 10 raised to the power of -10. Now you have to tell the answer in terms of picofarads. देखो pico क्या होता है? बेसिकली 10 - 12 की पावर. सो आई विल मूव दिस वैल्यू 2 powers ahead. So capacitance will become 280 into 10 raised to the power minus 12. This minus 12 can be replaced as pico. So capacitance is 280 picofarads. A second capacitor is connected into the circuit of figure 6.2. ठीक है. The two capacitors are connected in parallel. This is the important word. State and explain the change, if any, in the average current in the capacitor. Okay. Average current in the ammeter. Okay. अब हो ये रहा है कि आप पैरेलल में एक और कैपेसिटर कनेक्ट कर रहे हो इस तरह. What will this do? This will increase the capacitance. बेटा कैपेसिटेंस अगर इंक्रीज होगी, सो विच फॉर्मूला हैव वी स्टडीड? Q इज इक्वल टू CV. वोल्टेज कांस्टेंट ही रहेगा. अगर कैपेसिटेंस इंक्रीज होगी तो चार्ज विल इंक्रीज बिकॉज कैपेसिटेंस एंड चार्ज आर डायरेक्टली प्रोपोर्शनल. इफ चार्ज इंक्रीजेज व्हाट विल हैपन टू द एमीटर की रीडिंग? एमीटर की रीडिंग विल इंक्रीज एज वेल. नाउ आई डोंट नो कितने मार्क्स का सवाल है, 1 का है या 2 का है? 2 मार्क्स है. सही है. सो वी विल हैव टू टेल एवरीथिंग. As capacitance increases, what will happen? Charge increases, and as charge increases, the reading on ammeter increases. अगर सिर्फ स्टेट का वर्ड लिखा होता तो सिर्फ आप स्टेट कर देते कि एमीटर की रीडिंग इंक्रीज हो रही है, दैट्स इनफ. और अगर 1 मार्क का सवाल होता तो भी सिर्फ यही लिखते. बट सिंस इट इज अ 2 मार्क्स का सवाल, वी हैव टू राइट द एंटायर एक्सप्लेनेशन. लेट्स सी. या करंट इंक्रीजेस, करेक्ट, हमने सही लिखा था आंसर. लेट मी चेक द अदर आंसर एज वेल. यस, वी वर करेक्ट. लेट्स मूव ऑन टू द नेक्स्ट क्वेश्चन. डिफाइन द कैपेसिटेंस ऑफ अ पैरेलल प्लेट कैपेसिटर. भाई पैरेलल प्लेट कैपेसिटर के लिए हमने कैपेसिटेंस डिफाइन करनी है. Now to define the capacitance of a parallel plate capacitor, initially हमारे दिमाग में क्या आएगा? We will say कि सर capacitance का फॉर्मूला होता है charge divided by voltage. So I will say charge per unit potential difference. This will only net you 1 marks. 2 marks का सवाल है, so you have to give the definition in a sophisticated manner. ठीक है. So what will you say? Charge on one plate. Because in capacitance you always take, ये charge जो होता है ना, this charge is the charge on one plate. ठीक है. So charge on one plate divided, या you can say charge on one plate per unit potential difference अक्रॉस द प्लेट्स. ठीक है. पोटेंशियल डिफरेंस दोनों प्लेट्स के अक्रॉस होता है और चार्ज सिर्फ एक प्लेट का लिया जाता है. इफ यू हैव टू कैलकुलेट द कैपेसिटेंस पर यूनिट पोटेंशियल डिफरेंस अक्रॉस द प्लेट्स. ओके. लेट्स मूव ऑन टू पार्ट 2. स्टेट 3 फंक्शंस ऑफ कैपेसिटर्स इन इलेक्ट्रिकल सर्किट्स. व्हाट इज द फर्स्ट फंक्शन? स्मूथिंग. ये हम आगे एसी करंट्स में भी देखेंगे. सेकेंड फंक्शन इज ऑफ स्टोरिंग एनर्जी. यहां पे कभी भी चार्जेस ना लिखना, हमेशा कैपेसिटर नेवर स्टोर्स चार्जेस, कैपेसिटर ऑलवेज स्टोर्स एनर्जी. एंड द थर्ड फंक्शन इज टू बी यूज्ड इन टाइम डिले सर्किट्स. सिंपल एज दैट, नथिंग कॉम्प्लिकेटेड. A student has available 4 capacitors. Each of the capacitance is 24 microfarads. The capacitors are connected as shown in figure 6.1. Calculate the combined capacitance. यार इन सबकी combined capacitance निकालनी है. How will you calculate that? If you look closely, ये वाला capacitor, like let me highlight it. This yellow highlighted capacitor, this yellow highlighted capacitor, and this yellow highlighted capacitor, all of them are in series. So I can draw the circuit something like this. Something like 1 second XY ये आ गया और ये सारे सीरीज में. So what I can do is 24 microfarad and here 24 microfarad and again 24 microfarad, something like this. ठीक है. So do you remember what used to happen to capacitance in series? Yes. 1 upon total capacitance is equals to 1 upon 24 plus 1 upon 24 plus 1 upon 24. So I can replace all of these three capacitance with a single capacitor. That will be what? That will be 8 microfarads ka capacitor. You can calculate it using this formula. I have already done the calculation. Now 8 microfarads and 20 microfarads are in parallel. So do you remember how did we used to calculate parallel mein capacitance? Capacitance total. Okay, this is the total capacitance for the branch 1. This is the total capacitance for the entire circuit. 24 plus 8, that is equals to 32 microfarads. You will write 32 here. Simple as that, nothing complicated. Now, yeah, perfect. Chalo, let's further move ahead. Figure 6.1 shows a capacitor connected in series with a resistor of resistance R. ठीक है, एक capacitor है that is connected to a resistor of resistance R. Okay, let's see the diagram as well. Initially the switch is open. Okay, initially the switch is open, perfect, and there is a potential difference of 12 volts across the capacitor. ठीक है, 12 volts जा रहे हैं across the capacitor. Here is 12 volts. ठीक है, switch is open. At time t is equals to 0, the switch is closed such that there is a current I in the resistor. Figure 6.2 shows the variation of current with time. Okay, current versus time का graph हमें given है. This is the current versus time graph for what? For the resistor. This is the current versus time graph for the resistor. Chalo, let's further move ahead. Explain the shape of the line in figure 6.2. We have to explain the shape of this line in figure 6.2, and it is a 3 marks question. So we have to write the answer in a logical manner. So how will we phrase this answer? First of all, we will say that the potential difference across resistor is equal to what? Potential difference across the capacitor. ठीक है, कैपेसिटर के अक्रॉस जो पोटेंशियल डिफरेंस है दैट इज इक्वल टू द पोटेंशियल डिफरेंस अक्रॉस द रेजिस्टर. देन व्हाट वी विल से दैट द पोटेंशियल डिफरेंस अक्रॉस कैपेसिटर is what? Is directly proportional to the charge. And as the potential difference across the capacitor will decrease, the charge in the circuit will decrease. And since we know that current is equals to charge divided by time, अगर charge decrease करेगा बेटा, current will also decrease. And as charge keeps on decreasing, current decrease करता रहेगा. इतनी तो हमें बात दिख रही है from the graph. ठीक है, current decrease कर रहा है. अब last point here that you will write here, as current decreases, जैसे जैसे current decrease होगा, the rate of decrease of current will also decrease. The rate of decrease of current will also decrease. अब इसका मीनिंग क्या है? If you see here in the initial region, in the yellow highlighted region, yellow highlighted को यहाँ तक कर दो, ठीक है. In this region the current is decreasing quite fast, but in this green highlighted region the current takes a larger amount of time to decrease. So what we will say, rate of decrease of current will also decrease. ठीक है, चलो let's move on to this part B. Use figure 6.2 to determine resistance R. Resistance R determine करनी है बेटा. Do we have the voltage? Yes, 12 volts. Current क्या है? चलो इसको calculate कर लेते हैं थोड़ा सा zoom in करके. Let's calculate the current. Current की line is here. That is 0.13 और मिली एम्पेयर है तो 10 raised to the power of -3 होगा. Okay. So our voltage is 12. Current is 0.13 into 10 raised to the power of -3. Can I calculate the resistance? Yes, V divided by I करके. V divided by I कर लो. Voltage is 12 divided by the current, that is 0.13 into 10 raised to the power of -3. What does the answer come out to be? Let's calculate that. Voltage 12 है बेटा, current is 0.13 into 10 raised to the power of minus 3. This comes out to be 1 second. Let's calculate that. 9.2 into 10 raised to the power of 4. Resistance comes out to be 9.2 into 10 raised to the power of 4 ohms. The time constant T of the circuit. Now we have to calculate time constant T of the circuit. What equation have we studied? Current I is equals to I naught exponential minus T divided by the time constant tau. Now, do we know the maximum value of current? I naught pata hai? Yes, 0.13. Now take any value of current and time. Let's take any value of current and time. Let's go here, and which is the most clear value? I think ये value ठीक है. Time is 4. 1 second, let me zoom in a bit. Time is, yes, 4, and current is somewhere around here. So let's say 0.5. ठीक है. Current is 0.5. Let's place 0.5 here. I naught is 0.13. Sorry, not 0.5. It is 0.05. Yes, it is 0.05. Yes, 0.05. Let me label it correctly as well. This is 0.05. Chalo, let's put it here. 0.05. I naught is 0.13. E minus time की value क्या आ रही थी? 4 divided by tau. So let's calculate the value. ln of 0.05 divided by 0.13 is equals to minus 4 divided by tau. Tau की value किसके equal आ जाएगी? Minus 4 divided by ln 0.05 divided by 0.13. Let's calculate that. Minus 4 ln and answer में 0.05 divided by 0.13. This comes out to be what? 4.2 is your answer. Time constant comes out to be 4.2. Chalo, let's further move ahead. Use your answer in part B to determine capacitance C. We have to determine the capacitance C. What do we know? Tau is equals to R into C. Tau क्या आ रहा था? 4.2. Resistance, did we calculated it? Yes, 9.2 into 10 is the power of 4. 9.2 into 10 is the power of 4. Capacitance C किसके equal आ जाएगी? Let's calculate that. Answer divided by 9.2 into 10 is the power of 4. Capacitance C comes out to be 4.6 into 10 raised to the power 5. 4.6 into 10 raised to the power of minus 5 farads is your capacitance. Simple as that, nothing complicated. Let's move on to the next question. Chalo, let's see this. Two capacitors X and Y are connected in series to a power supply of voltage V as shown in figure 6.1. ठीक हो गया. Now, let's further see it. The capacitance of X is Cx. ठीक है. Capacitance of X क्या है भाई? Cx है. ठीक है. And the capacitance of Y is Cy. ठीक है. Capacitance of Y is Cy. Drive an expression in terms of Cx and Cy for the combined resistance of the capacitor Ct in the circuit. Explain your reasoning. Okay. बेटा सीरीज में एक बात हमेशा हमने याद रखनी होती है कि चार्ज on one capacitor is equals to the charge on the other capacitor. Okay. And that is equals to the charge of the battery, that is the total charge. Okay. So I can write it here. The total charge is equals to the charge on X is equals to the charge on Y. Also, the total voltage V is equals to the voltage on X plus the voltage on Y. Now, do you remember that voltage can be represented as charge divided by capacitance? So let's replace this Vx and Vy with charge divided by capacitance. Total voltage is equals to charge on X divided by capacitance of X plus 1 second plus the charge on Y divided by capacitance of Y. And total voltage can be written as what? total voltage can be written as the total charge divided by the total capacitance. Now I know that the total charge is equal to the charge on X is equal to the charge on Y. What can I do? I can take charge as common. One upon Cx plus 1 upon Cy. Charge will get cancelled out. This charge and this charge will get cancelled out. 1 upon Ct is equals to 1 upon Cx plus 1 upon Cy. Simple as that. Two capacitors P and Q are connected in parallel to a power supply of voltage V. Okay, now two capacitors are connected in parallel. Now let's make those capacitors like this. Okay. पैरेलल में कैपेसिटेंस को क्या होता था? लेट्स से दिस इज पी, दिस इज क्यू. कैपेसिटेंस को क्या होता था पैरेलल में? दे यूज्ड टू ऐड अप लाइक दिस. ओके, द कैपेसिटेंस ऑफ पी इज दिस एंड क्यू की कैपेसिटेंस कैन बी वेरीड फ्रॉम 0 एंड 400 माइक्रोफैरड्स. ठीक है. When capacitance of Q is 0, the total energy stored in the capacitor is this. Show that the voltage supply is this. Okay. Energy is equals to what? 1 upon 2 CV square. Now the C here is the total capacitance. If the C of capacitance Q is 0 and capacitor P की C क्या है? 200. What will be the total capacitance? 200 microfarad. You can place C की जगह about 200 microfarad. 1 upon 2 into 200 into 10 raised to the power of -6. Voltage की वैल्यू हमें नहीं पता. Place a V square here. Do we know the energy की value? Yes, 2.5 millijoules. Place 2.5 millijoules here. 2.5 into 10 raised to the power of -3. Can I calculate voltage की value? Yes, easily. Let's do that. 2.5 into 10 raised to the power of -3 multiplied by 2 and answer divided by 200 into 10 raised to the power of -6 under root your answer. The voltage की value comes out to be 5 volts. Correct. So we are moving good up till now. Calculate the total energy in millijoules stored when the capacitor CQ has its maximum value. Capacitor C की maximum value क्या है? 400 microfarads. If CQ has 400 microfarads, total capacitance क्या हो जाएगी? 400 plus 200, that is 600 microfarads. What will the energy be equal to now? 1 upon 2 CV square. C किसके equal है भाई? 600 microfarads. 600 into 10 raised to the power of -6. Voltage की value क्या है? 5 का square. Let's calculate the answer. 600 into 10 raised to the power of -6 multiplied by 25 divided by 2. This comes out to be what? 7.5 into 10 raised to the power of -3 joules. Or you can say 7.5 millijoules. Okay. Now you have 7.5 की value millijoules at 400 microfarads. And what was millijoules on? 2.5 millijoules when the capacitance is 0. You can draw a line between them. Let's draw a line between them like this. Simple as that. This will get you 2 on 2. Simple. Nothing complicated. Let's see the answer. Straight line with positive gradient. Correct. Yeah, we were going good. Chalo. Let's move on to the next question. Determine the total capacitance in microfarads of the three capacitors. बेटा 10 and 20 क्या हो जाएंगे? Add up हो जाएंगे because they are in parallel. So you will have the circuit something like this. 45 microfarads in series with 30 microfarads. If both of them are in series, which formula will we apply? 1 upon Ct is equals to 1 upon 45 plus 1 upon 30. Let's calculate it. 1 divided by 45 plus 1 divided by 30. 1 divided by whole answer. This comes out to be 18. Total capacitance is 18 microfarad. A capacitor of capacitance 45 microfarad is connected to a variable power supply initially set at 8 volts. ठीक है. The output of the power supply increases so that the potential difference across the capacitor increases to this value. Calculate the increase in energy stored in the capacitor. We have to calculate the change in energy. Change in energy is equals to what? 1 upon 2 C. Change in voltage का square. What is C? 45 microfarads. 45 into 10 raised to the power of minus 6. What is change in voltage? Change in voltage is 9.6 का square minus 8 का square. Let's calculate the answer. 9.6 का square minus 8 square multiplied by 45 into 10 raised to the power of minus 6 divided by 2. This comes out to be what? 6.3 into 10 raised to the power of minus 4. 6.3 10 raised to the power of minus 4 joules. A sinusoidal AC power supply is connected to the input of a bridge rectifier. Okay. The output of the rectifier is connected to a load resistor. Okay. Complete the circuit in figure 4.2 by adding a capacitor to smooth the potential difference across the load resistor. Okay, so first of all, let's close these leads and then add a capacitor like this. Or you can do one thing. You can add a capacitor like this. Okay, this is a more appropriate diagram. The variation with time t of the potential difference of the smoothened output is shown in figure 4.3. Okay. Determine the time constant in millisecond of the smoothened circuit. बेटा time constant के लिए कौन सी equation लगाते थे? V is equals to V naught exponential minus t divided by tau. यहाँ पे maximum voltage क्या है भाई? Maximum voltage is 4. After, let's say here, yeah, here the voltage is, let's say this line, this is 3.2. ठीक है, ये 3.2 है. How much time has it taken? बेटा 1 second. You have moved from this peak value to this 3.2 की value. कितना time elapse हुआ है? Let's calculate that. ये कितने seconds है यहाँ पे? This second is 13. You have started from 5. You have ended at 13. कितना time elapse हुआ है? 8 seconds. So E minus 8 divided by tau. Let's now calculate tau. Ln 3.2 divided by 4 is equals to minus 8 divided by tau. Let's calculate tau यार. ये तो पिछले सवाल जैसा ही सवाल है. Identical है. 3.2 divided by 4. What will be the answer? 35.9. Tau is equals to 35.9 milliseconds. A sinusoidal AC power supply has a maximum power of 16 volts. State the value of the mean power when the output of the power supply is full wave rectified. बेटा mean power किसके equal होती थी? Mean power used to be equal to peak power divided by 2. 16 divided by 2, this equals to 8 volts. When the wave is half wave rectified, यार half wave rectified होगी तो क्या होगा? Half values positive होंगी, half zero. Half positive, half zero. Half positive, half zero. So the power की value will further be divided by 2. 4 votes will be your answer. यहाँ पे 8 votes will be your answer. This is what I think. Let's confirm the answer. Yes, 36 milliseconds is correct. यहाँ पे 36 milliseconds क्यों आ रहा है बेटा? Because they have rounded off to 2 significant figures. हमने 3SF लिया है. अगर हम भी 2SF ले लें तो हमारा भी 36 ms आ जाएगा. No big deal in this. Let's further see. बाकी answers correct हैं. Yes, all of them are correct. Good. Let's move on to the next question. Define the capacitance of a parallel plate capacitor. So what will you say? When a voltage is applied across the plates, what happens? This causes the charges to separate, and the separation of charges stores energy, and the separation of charges stores energy. Simple as that. Let's further move ahead. A student has 3 capacitors. 2 of the capacitors are 4 microfarads and 1 is 8 microfarads. Draw labeled circuit diagrams, one in each case, to show how the 3 capacitors may be used या connected to give a total capacitance of, let's see, आपके पास 2 कैपेसिटर्स हैं और 4 माइक्रोफैरेड्स और एक कैपेसिटर है 8 माइक्रोफैरेड्स का. सो लेट्स सी, इफ यू हैव टू क्रिएट अ 1.6 का माइक्रोफैरेड, सो हाउ विल यू प्लेस द 3 कैपेसिटर्स? व्हाट कैन यू डू हियर? यू कैन कनेक्ट all the 3 capacitors in parallel. 8, 4 and the other 4 will be connected in parallel to give a combined value of 1.6. 1 upon Ct is equals to 1 upon 8 plus 1 upon 4 plus 1 upon 4. This comes out to be what? Let's calculate that. 1 upon plus 1 upon 8, 1 divided by answer. This comes out to be 1.6 microfarads. Let's see how will we create 10 microfarads. Beta 10 microfarads create करने के लिए what can we do? We can take an 8 microfarad capacitor and place it in parallel with the 4 microfarads वाले capacitors in series. What will the combined capacitance of this branch become? इन दोनों की combined capacitance क्या बन जाएगी बेटा? 1 upon 4 plus 1 upon 4 is equals to 1 upon Ct. Ct comes out to be 2 microfarad. If this entire branch is 2 microfarad, the above one is 8 microfarad. If you add them up, total capacitance will come out to be 10 microfarad. Let's see part C. A capacitor C of capacitance 47 microfarad is connected across the output terminals of a bridge rectifier as shown in figure 6.1. ठीक हो गया. The variation with time t of the potential difference across the resistor is shown in figure 6.2. Okay. Use data from figure 6.2 to determine the energy transfer from the capacitor to the resistor between time t is equals to 1 and time t is equals to 2. Okay. बेटा हमने टाइम t1 से लेकर t2 तक एनर्जी ट्रांसफर देखना है कितना हो रहा है फ्रॉम कैपेसिटर टू द रेजिस्टर. बेसिकली जब कैपेसिटर डिस्चार्ज हो रहा होता है तभी कैपेसिटर ट्रांसफर कर रहा होता है एनर्जी फ्रॉम इटसेल्फ टू द रेजिस्टर. तो हाउ विल वी कैलकुलेट दिस एनर्जी? वेरी इजी. चेंज इन एनर्जी इज इक्वल्स टू 1/2 c इंटू चेंज इन वोल्टेज का स्क्वायर. बेटा आपको कैपेसिटेंस की वैल्यू पता है? यस 47. सो 1/2 into 47 10 raised to the power of minus 6. change in voltage क्या होगा? This value, let's say this initial value is what? Let me zoom in a bit. ये exact middle में है ना, तो let's respect that middle value. यहाँ पे है. So if we have 5 boxes between 2 units, तो 2.5 boxes किसके equal होगा? 1 unit के equal. This becomes 7 volts और डिस्चार्ज पे क्या वैल्यू आ रही है? 4 volts की. ओके तो इनिशियल वोल्टेज क्या हो जाएगा भाई? 7 का स्क्वायर. फाइनल वोल्टेज क्या, सॉरी यस फाइनल वोल्टेज कितना हो जाएगा? 4 का स्क्वायर. लेट्स कैलकुलेट दिस आंसर. 7 का स्क्वायर माइनस 4 का स्क्वायर मल्टीप्लाइड बाय 47 इंटू 10 raised to the power of minus 6. ओके डिवाइडेड बाय 2. दिस गिव्स यू एन आंसर ऑफ व्हाट? 7.8 into 10 raised to the power of minus 4 joules. Simple as that, nothing complicated. यही आ रहा है? Yes, यही आ रहा है. Let's further move ahead. A capacitor is charged, okay, so that the potential difference V across its terminal is 8 volts. ठीक है. The capacitor is connected into the circuit of figure 6.1. Okay. The switch is initially open. The switch is closed at time t is equals to 0 second. Okay. Figure 6.2 shows the variation of voltage with charge on the plates of capacitor C as the capacitor discharges. Okay. Voltage versus charge का ग्राफ given है as the capacitor discharges. ठीक हो गया. On the plates of the capacitor as the capacitor discharges. Show that the energy stored in the capacitor at time t is equals to 0 is 1.8 millijoules. Okay. How will we calculate this energy? बहुत easy है. You will calculate the area under this graph. 1 second. Let me first of all check this value. This is round about what? This is round about 450. And what is the height? 8. Can I calculate this area? Can I calculate this area under the graph? Yes or no? Yes, I can do that. 1 upon 2 into 8 into what is the base? 450 into 10 raised to the power of minus 6. This becomes 1, this becomes 4. 450 into 4, this becomes 1800 into 10 raised to the power of minus 6. 1800 into 10 raised to the power of minus 6 is your energy. So, can I move this decimal point 3 places backward? Yes. 1.8. 10 की power 3 बढ़ जाएगी, minus 3 हो जाएगा. 10 minus 3 is equals to milli. So 1.8 millijoules. Determine the capacitance of the capacitor C. Give your answer. Okay. How will we determine the capacitance? We know capacitance is equals to charge divided by voltage. What is the charge? 450 into 10 raised to the power of minus 6. What is the voltage की value? 8. Divide both of them. 450 into 10 raised to the power of minus 6 divided by what is the voltage? 8. This comes out to be 5.6. Capacitance comes out to be 5.6 into 10 raised to the power of minus 5 farads. Simple as that, nothing complicated. You can place it here, 5.6 into 10 raised to the power of minus 5 farads. Let's further move ahead. Figure 6.3 shows the variation with time t of minus ln voltage divided by 8 volts. ठीक है. Show that when t is equal to 1 time constant, the value of minus ln V over 8 volts is equal to 1. Okay, let's do that. बेटा हमने decay equation क्या पढ़ी है? V is equals to V naught E minus T divided by tau. Now if time is equals to 1 time constant, मतलब time की value is equals to tau. So place it. Maximum voltage क्या था? 8. V comes here. Okay. E minus T divided by T की जगह हम क्या प्लेस कर देंगे? टाउ. लेट्स प्लेस इट. और टाउ तो यहाँ पे मिडिल में है ही. ठीक है. नाउ व्हाई हैव आई प्लेस दिस V? दिस इज वोल्टेज का साइन. दिस इज वोल्टेज का सिंबल. सिंपल एज दैट, नथिंग कॉम्प्लिकेटेड. नाउ वी विल टेक ln ऑन बोथ साइड्स. ln V divided by 8V. Okay. Is equals to ln E minus 1. This and this get cancelled out. Minus ln V over 8V is equals to 1. Simple as that. This is what we had to show. Determine the time constant T of the circuit in figure 6.1. Okay. We have to determine the time constant of the circuit in figure 6.1. Okay. So let's do that. Figure 6.1. ठीक है. ये figure है. ये हमारे पास यहाँ पे values given है. Now what I can do is I know when this value is equals to 1, ये value जब 1 के equal होगी तब my time will be equal to time constant. So what I do is मैं इस value को 1 के equal देख के time की value calculate करता हूँ. Let's say this comes out to be what? 3.2. Why did I apply this procedure? बेटा मुझे पता है when minus ln V divided by 8V is equals to 1, my time will be equal to tau. So मैं यहाँ पे गया 1 की वैल्यू ली for minus ln V divided by 8V और वहाँ पे टाइम देख लिया. This time will equal to what? Time constant. A very easy and simple way. थोड़ी सी अक्ल लगाई, हमने ज़्यादा कुछ नहीं किया. Calculate the resistance R. Now we know time constant is equals to RC. टाइम आपके पास आ गया 3.2 सेकेंड जी आया. आई गेस यस सेकेंड जी आया. यू हैव द कैपेसिटेंस की वैल्यू. यस 5.6 इंटू 10 रेज़्ड टू द पावर ऑफ माइनस 5. ओके. रेजिस्टेंस की वैल्यू आ जाएगी 5.6 इंटू 10 रेज़्ड टू द पावर ऑफ माइनस 5. अगर यहाँ पे प्लेस करोगे विल यू गेट द रेजिस्टेंस? यस 3.2 डिवाइडेड बाई 5.6 इंटू 10 रेज़्ड टू द पावर ऑफ माइनस 5. दिस कम्स आउट टू बी 1 second, लेट मी पुट इट इन स्टैंडर्ड फॉर्म. 5.7 into 10 raised to the power of 4. Resistance is equals to 5.7 into 10 raised to the power 4 ohms. चलो let's further move ahead. Is there any question? नहीं. Just check the answers. ये सही है, ये सही है. This is correct. This is correct as well. Perfect. Let's move ahead. Two capacitors A and B are connected into the circuit as shown in figure 5.1. ठीक है. Two capacitors are connected as shown in figure 5.1. Capacitor A has a capacitance of C. Okay. Capacitor B has a capacitance of 3C. Okay. The electromotive force of the cell is V. Okay. The two-way switch is initially at position X. Okay. And the capacitor is initially uncharged. Okay. Capacitor B is initially uncharged. Okay. State in terms of voltage and capacitance the expression for the initial charge QA on the plates of capacitor A. You have to calculate the charge QA. How will you do that? Very easy. Charge किसके equal होता है भाई? Capacitance into voltage. So this is your answer. The charge at A will be equal to the capacitance C multiplied by the voltage. The initial energy is stored in capacitor A. That is also very easy. 1 upon 2 C V square. Let's further move ahead. The two-way switch is now moved to position Y. State and explain what happens to the charge that was initially on capacitor A. भाई इनिशियली जो चार्ज कैपेसिटर, अब आप क्या कर रहे हो बेसिकली, लेट मी ड्रॉ द डायग्राम एज वेल. यू हैव मूव द स्विच इन अ वे दैट इट इज नाउ एट वाई लाइक दिस. अब वो वाई पे इस तरह है, ठीक है. नाउ यू हैव टू टेल व्हाट हैपेंस टू द चार्ज दैट वाज इनिशियली ऑन ए. इनिशियली जो चार्ज ए पे था अब उसके साथ क्या हो रहा है. नाउ द चार्ज स्टार्ट्स टू मूव टूवर्ड्स व्हाट, towards capacitor B. Capacitor B. The flow of charge stops. The flow of charge stops when what? When potential difference on A is equals to the potential difference on capacitor B. Simple as that. Let's further move ahead. Show that the final potential difference VB across capacitor B is given by this value. ठीक है. We have to show that VB is given by this value. Okay. But we know that the charge on A is equals to what? CV. And when we connect the switch to point Y, what will happen? This charge CV will get divided into two. One will be the charge on A and one will be the charge on B. ठीक है. You further know that the charging process will stop when the voltage at A is equals to voltage at B. तो हम ये कर सकते हैं कि CV कैपेसिटेंस एट A क्या है C, वोल्टेज एट ए को वोल्टेज एट बी से रिप्लेस कर देते हैं. बिकॉज बोथ द वोल्टेज जब सिमिलर होंगे तभी डिस्चार्जिंग का प्रोसेस स्टॉप होगा. कैपेसिटेंस सी बी किसके इक्वल थी? 3C. वोल्टेज वी बी. लेट्स रीअरेंज द आंसर. सी वी इज इक्वल टू 4C वी बी. C and C get cancelled out. V divided by 4 is equal to the voltage at B. This is your final answer. Determine the expression in terms of V and C for the decrease in total energy. Now you have to calculate the decrease in total energy by initial energy minus final energy. Okay. What was the initial energy? 1 upon 2 CV square. What was the final energy? 1 upon 2. C की जगह क्या रखेंगे? 4C. V की जगह क्या रखेंगे? V upon 4 whole square. This becomes 1, this becomes 2. 1 upon 2 CV square minus 2C multiplied by V square divided by 16. This becomes equals to what? Let's further calculate it. 1 upon 2 CV square minus 1 and 8, 1 upon 8 CV square. ठीक है. अब क्या करेंगे? LCM लेंगे. Multiply this by 4 and multiply this by 4. तो 4 CV square minus CV square divided by 8. The answer comes out to be 3 upon 8 Cv square is your decrease. Simple as that. Okay, this is the answer. Correct everything. Yeah, we have done the procedure as well. Correct. ठीक हो गया. अब इस सवाल पे आ जाओ. Part of an electric circuit is shown in figure 5.1. Okay. The circuit is used to produce half wave rectification. Okay. Half wave rectification में एक ही diode use होता था. Of an alternating voltage of potential difference V in. The output potential difference across the 40 kilo ohm resistor is V out. Okay. A component is missing from the circuit of figure 5.1. ठीक है. एक component missing है from the circuit 5.1. Okay. Complete the circuit diagram in figure 5.1 by adding the circuit symbol for the missing component. What will we add? We will add a diode because I can't see a diode in this entire circuit. And the examiner has said that this is a half wave rectification ka circuit. So there must be a diode present. A capacitor C is shown in the circuit of figure 5.1. ठीक हो गया. State the effect of V output. State the effect on V output of including the capacitor in the circuit. भाई capacitor include करने से क्या होगा? The output will smoothen. V output will smoothen. V output will smoothen. Let's move on to part B. Figure 5.2 shows the variation with time t of voltage in. ठीक है, voltage in versus time का graph given है. Okay. Figure 5.3 shows the variation with t of voltage output. Okay, voltage output का graph भी given है. Determine the frequency of voltage in. We have to determine the frequency of voltage in. How much time is it taking for one wave to get completed? ये yellow वाली wave कितनी देर में complete हो रही है? 0.04 seconds. Time period is 0.04 seconds. What will be the frequency? 1 divided by 0.04. Let's divide the answer. 1 divided by 0.04. This comes out to be 25 Hertz. Frequency किसके equal आ गई? 25 Hertz. Show that the time constant t for the discharge of the capacitor through the resistor is this. We have to show that the time constant is this. So which equation will we use? V is equals to V naught E minus t divided by tau. बेटा maximum voltage क्या है? Let's see here. Let's zoom in. Maximum voltage क्या है? This is 10 boxes give you a unit increment of 2.5. 10 boxes में आपका कितने यूनिट का इंक्रीज हो रहा है? 2.5. 1 boxes will give you an increment of 0.25. So this is 5.5. Peak voltage क्या है भाई? 5.5. Place it here. Now let's see the voltage here. The voltage here is 3.25. Okay, and the time it takes for discharge is what? ये कितना टाइम ले रहा है भाई डिस्चार्ज के लिए? 0.02 से 0.04 कितना टाइम कवर हो रहा है? 0.02 सेकेंड्स. ओके, वोल्टेज V की वैल्यू क्या है? 3.25 E माइनस टाइम कितना कवर हो रहा था? 0.02 divided by tau. Okay, now let's take an ln of 3.2 divided by 5.5 is equals to minus 0.02 divided by tau. Okay, tau comes out to be equal to what? Minus 0.02 divided by ln 3.25 divided by 5.5. What is your answer? Let's calculate that. Minus 0.02 divided by ln, answer will be equal to 3.25 divided by 5.5. The answer comes out to be 0.038. Yes, so the time constant is correct. टाइम कांस्टेंट हमने करेक्ट निकाला है, दैट इज 0.038 सेकेंड्स. यही निकालना था. ठीक है, कैलकुलेट द कैपेसिटेंस ऑफ सी. अब कैपेसिटेंस ऑफ सी किस तरह निकलेगी? वी नो दैट टाइम कांस्टेंट इज इक्वल्स टू आर सी. रेजिस्टेंस गिवन है भाई, रेजिस्टेंस इज 14 किलो ओम. सही है. टाइम कांस्टेंट इज 0.038 डिवाइडेड बाय रेजिस्टेंस क्या है? 14 इंटू 10 raised to the power of 3. कैपेसिटेंस आ जाएगी? यस आ जाएगी. लेट्स कैलकुलेट दैट आंसर. डिवाइडेड बाय 14 इंटू 10 raised to the power of 3. This gives you an answer of what? 2.72 2.72 into 10 raised to the power of -6 farads. Simple as that. The circuit of figure 5.1 is modified so that it produces full wave rectification of an input voltage. Suggest with a reason how output voltage now varies with time when V in is as shown in figure 5.2. यार अगर आपका V इनपुट इस तरह है और आप फुल वेव रेक्टिफिकेशन कर रहे हो तो बेसिकली क्या होगा, आपकी एक कांस्टेंट लाइन आ जाएगी वोल्टेज की. क्यों? क्योंकि देखो पॉजिटिव वोल्टेजेस तो पॉजिटिव ही रहते हैं फुल वेव रेक्टिफिकेशन में, नेगेटिव वाले भी पॉजिटिव हो जाते हैं इस तरह, दिस विल रिमेन पॉजिटिव, और नेगेटिव वाले भी पॉजिटिव में टर्न हो जाते हैं. सो यू विल हैव अ स्ट्रेट लाइन, a constant voltage without any fluctuation. You can write here constant voltage without any fluctuations, without any fluctuations. Simple as that. So this marks the end of the capacitance ke past papers. If you have further any questions or confusions, you can ask me in the comments below. The document is attached in the description. You can download it from the drive link. Thank you for watching.